Okay, hello everyone. My name is Xavier Struthers. I'm going to be presenting deepfake detection for Team 4. Team 4 consists of Zachariah Lunsford, Amun Jackson, Kenneth Howard, and myself, presenting to class for the Comp 651. Um, Next slide. And what we're going to be talking about is deepfake detection. So the data set obviously involves deepfakes. The full data set is 471 gigs of 10-second videos. So about 402 gigs, or excuse me, 402 videos, with accompanying those videos are target labels of real or fake for each. So makes it pretty obvious that with that label, some of the key challenges are the data set size, being that 400 gigs, 470 gigs is quite a lot. But the 402 videos can be seen as a small data set for some of the circumstances. So the data set size as well as the balance, I believe more of the uh, data was fake as opposed to real videos, as well as the video quality can be poor in some of the videos. So whether it be the manipulation techniques that were used or just the camera or whatever the situation is, some of those can be kind of hard to detect or hard to recognize some of the features that are within that. Um, Here are two examples of what that deep fake would look like. So on the left, it's a little bit more obvious than the one on the right, but they are both deep fakes here. Um, so just wanted to give you an example before moving on with the data that we're working with. So some of the trends, some of the literature review highlights that we found, some of the trends. Um, there seems to be a big shift towards models that generalize across data sets. Um, in the kind of modern world, you need kind of a singular way to classify whether a video is a deep fake or a real video. So there's been a shift away from the simple frame-based CNN architectures to more physiological behavioral cues. So like arm movements, blinking patterns, things that are harder for the deep fakes to replicate consistently. So, um, as well as like a multimodal fusion, so like mismatching of, you know, mouth to the words they're saying or the actions they're doing. Those kind of mismatches um, are kind of being emphasized in the approach. So, some of the limitations, like I said before, some of the video quality was pretty poor. So that has a lot to do with the lighting, the motion, and um, some of the uh, application to the real world use. So some of these deep fakes, you can probably go online to like a website for deep fakes and create a deep fake. Those are sometimes harder to detect than uh, the standard deepfake. So in phase two, um, we replicated a study on the Gen D methodology, which uh, really emphasized promoting generalization across uh, deepfake detection research. So building pretty much a single model to help differentiate across, data that isn't necessarily trained on by the model. So um, we tried our best to align the training from the study to what we implemented in phase two. So that included the pre-processing pipeline, the model training, as well as the evaluation. Um, so um, with the pre-processing, there was frame sampling. With the model training, we use a clip frozen pre-training with a layer norm and a small linear classifier for training. And then we evaluated that based on the AROC, accuracy, precision, F1, and recall, which isn't listed here. So we were actually able to successfully replicate the results from that study to the new study, or from that old study to our new model here. And these were the results. So um, pretty low um, area under the curve score. But for the most part, the other evaluation metrics we thought were pretty positive. So we kind of left phase two feeling pretty good about the implementation. Felt like we had a good foundation for the implementation. Obviously, the area under the curve needs improvement. And then we found with the recall being 100% there that a lot of the real videos are getting flagged as deep fakes. So we were kind of getting a lot of false alarms there. Um, obviously that's not good. That's kind of an indicator of overfitting. So we need to have a strong balance between catching the fakes and avoiding those false alarms that we talked about. So our initial plan with phase three was just to improve it. So improve the metrics while preserving the high recall. And we'll talk about the recall in just a second. And then compare kind of how those uh, results turned out. So all those evaluation metrics that we talked about, the and how we interpret those metrics to improve or not improve the generalization and the overfitting. And we also had some goals in mind, or some testing in mind for the frame sampling and a different backbone for the model. So we implemented those changes. So we did eventually put that phase two 100% recall into context and realized that it was some overfitting going on with the model um, through several different tweaks or iterations. We steadily improved. So we increased the frame sampling from 8 frames to 32 frames um, to help um, that overfitting and get better overall coverage. And then we swapped out the clip, I believe is VIB backbone to VIT 16 backbone. So more features were captured through those updates. And these are our results. So as you can see, a much improved area under the curve score, um, as well as very similar, slightly improved accuracy and precision. Um, the recall was slightly diminished, which in our view after discussions was probably a good thing. 100% probably raised some red flags. And overall, we got a more generalized model. So success, pretty much. So here is a division of work in that uh, progress that we have or that we've completed so far. Um, and overall, we learned quite a bit about deepfake detection and improving the generalization across data sets uh, with a great help from the team. We From the class and the team, we were able to combine and get some great results. So I appreciate the feedback and I appreciate the class. Everyone, have a great day. Thanks.